Hello everyone. We are diving into an introduction to thermochemistry. Okay. These are our learning objectives: to define energy, distinguish types of energy, and describe the nature of energy changes that accompany chemical and physical changes, to distinguish the related properties of heat, thermal energy, and temperature, define and distinguish specific heat, heat capacity, and describe the physical implications of both. Perform calculations involving heat, specific heat, and temperature change. Explain the technique of calorimetry. Calculate and interpret heat and heat-related properties using typical calorimetry data. These are the student learning objectives for thermochemistry overall. For this specific PowerPoint, we're going to create a formula sheet for the thermodynamic equations. We're going to define thermochemistry. We're going to be able to define endothermic reactions and the enthalpy change associated with endothermic reactions. We're going to be able to identify exothermic reactions and the enthalpy change associated with exothermic reactions. And we're going to be able to draw an enthalpy diagram for both endothermic and exothermic reactions. Okay. And this may sound a bit overwhelming, but this is more of an intro PowerPoint, so we're not really going to be doing a whole lot of math. This is just pretty much understanding conceptually about thermochemistry. For the next lecture, we're going to be diving into some math. These are the sections of thermochemistry in OpenStack. So we're going to have energy basics, calorimetry, enthalpy, and strengths of ionic and covalent bonds. So take some time to go through these next few slides and make a formula sheet, even though today we're pretty much just going to be going over concepts and the conceptual idea behind thermochemistry. To familiarize with these formulas when we start diving into the math, before we start diving into the math, will be helpful. At least you'll have seen these formulas before. I would say, like, put the name of what you're calculating. Like, you can say, for example, heat capacity, then write your formula, and then write what each variable stands for. Okay. And then some of this is just where it's been rearranged. Okay. So that way, because sometimes you'll have to, for heat capacity, you'll have to calculate heat instead of the heat capacity. For calorimetry, this tells you like what the whole equation is going to look like. So for Q reaction plus Q solution, you would have C reaction, M reaction, delta T reaction plus C solution, M solution, delta T solution. So just go through these and either write or type yourself up a formula sheet. Take a picture of that or take the Word document you've developed. You can literally just copy and paste this if you want. If it helps you to have something nice and neat and typed, if it helps you to write it out, do that. And then post that. This should be one of your assignments in Canvas. So energy basics. We're going to dive right in. Chemical changes and their accompanying changes in energy are important parts of our everyday world. There's another Canvas assignment. That's a discussion board post about everyday examples of thermochemistry. I did make some tweaks to it if you've already seen it. There's a few typos in there. But these are some examples you can talk about in that discussion. Okay. The reactions involved in the metabolism of food, the burning of fossil fuels, and the production of useful products or raw materials. Excuse me. And thermochemistry itself is defined as the study of heat absorbed or released during chemical and physical changes. So, a blast from the past. From earlier general chemistry. When we're breaking bonds, energy is required to overcome the attractive forces in a bond. Input of energy creates endothermic reactions. When you're making bonds, energy is released. I like to remember making bonds is like two people getting married. When you marry your partner and you bring two incomes together, hopefully that creates an excess of income because you're splitting bills. And so when you're making bonds, it's like you're getting married, so you have more money than you used to. So when you're money is kind of like the energy. When you come together to make those bonds, you release energy. Okay. And when you have a release of energy, that is an exothermic reaction. Talking about chemical reactions, we've been doing stoichiometry throughout general chemistry to talk about how chemical reactions occur and in what ratios they occur. And we get those ratios from the coefficients from a correctly balanced chemical equation. Now we're adding heat, light, and energy into the equation. When you release enough energy, you can see light, you can feel heat. But mainly we'll be talking about heat, but these can be used interchangeably within this PowerPoint. Okay, these three. And thermochemical equations are what I just described. They are balanced chemical equations that include energy changes in the form of heat, energy, or light in the reaction. Okay. So when you have an input of energy, you have an endothermic reaction, so energy is going to be on the left side with your reactants. When you have an exothermic chemical equation, heat is going to be part of your products. So when we talk about heat, how do we quantify it? Well, we treat heat as enthalpy, represented by the letter H, capital H. And enthalpy is the total heat of a chemical system. So a chemical system is a system that we set up that has a standard set of conditions. Right? It's kind of hard to measure the total heat of a system. It's a lot easier to measure the change in enthalpy. So we can measure the change in the temperature before the reaction occurs and the temperature after the reaction occurs. That's easier to calculate. So a change in enthalpy or the calculation that we that we mainly focus on. So we look at changes in enthalpy and we say, okay, is there a net gain or a net loss of heat within the system? A net gain in energy would be indicative of an endothermic reaction because input of heat is needed. The change in enthalpy is positive for an endothermic reaction. A net loss in heat would be indicative of an exothermic reaction, because the heat that was produced as the product is lost to the surroundings. The change in enthalpy is negative for an exothermic reaction. And if you look at there will be two video links for this PowerPoint. This link takes you to someone who does a very good job of explaining these chemical concepts with good illustrations in his videos. But you still want to watch this video in particular because this video goes over the review problems at the end. Okay. So if you want some good illustrations, I would say watch this video at the top, and then the link that'll be underneath once I'm done making this video will be not only this lecture part, but you have some review problems here at the end. Okay, and I'll be going over those. So we were here talking about enthalpy diagrams for endothermic reactions. So an enthalpy diagram, it doesn't really have a 0 point. You're just measuring the change in enthalpy, delta H over here. And so when we talk about endothermic reactions, you have an input of energy required. So the products have a higher change in enthalpy compared to the reactants. And I put a little bit more of an explanation here in the notes, pretty much because I didn't want to clutter the slide. And the notes say the product of an endothermic reaction gained the heat that was put in on the reactant side. The products gain that heat, which accounts for the greater enthalpy change in the products, which is why the products are up here and the reactants are down here. When you're drawing an enthalpy diagram for an exothermic reaction, the loss of heat to the environment when the products are formed, because of that, the reactants will have a higher change in enthalpy than the products. And at the bottom in the notes, I explain that the reactants lose the heat that is produced in the products. Because of this loss in heat, the reactants have a greater change of enthalpy than the products. Okay. If this seems a little bit confusing to you, the best thing I can say for endothermic and exothermic reactions, you can memorize it. Like this is for exothermic reactions, this for endothermic reactions. Okay. And so just to break this all down into a summary based upon the learning objectives for this specific PowerPoint, remember to write out your formula sheet for slides 6 through 12. You're asked to define thermochemistry. You're asked to be able to identify endothermic and exothermic reactions and the enthalpy changes associated with endothermic and exothermic reactions. And you are also asked to be able to draw an enthalpy diagram for endothermic and exothermic reactions. So just take some time to write a summary for your notes at the end of your notes, which is a good way to kind of summarize everything. And if you're not able to summarize it based upon the learning objectives at the beginning, then maybe that's where you can form specific questions to ask me, to ask your classmate, what have you. Okay. So we're going to go into some practice. True or false? For endothermic reactions, there is a net loss of energy. True or false? An endothermic reaction enthalpy diagram will show that the products have a greater change in enthalpy. True or false? We could not measure the change of heat in a system. Okay. So I'm assuming you took a second to attempt those questions, right? The first one is false. For endothermic reactions, you're going to have a net gain of energy. Okay. The second one is true. An endothermic reaction enthalpy diagram will show that the products do have a greater change in enthalpy. The third one is false. The main measurement that we have in enthalpy is the change in heat of a system, because that is easier to measure than the total heat of the system. And then, of course, in the notes I have more elaborated explanations if you'd like to read those. So take a second and practice this problem. Okay, draw an enthalpy diagram for the following reaction. So you're going to have to decide whether it's endothermic and exothermic, and then you're going to have to draw your diagram accordingly. Right, this is an endothermic reaction because you have an input of heat. So the products will have a higher enthalpy change than reactants. So your products are going to be up here and your reactants are going to be down here.